Welcome to Ask and Learn.
Hello and welcome to this video solution of Numerit. Here it's given that an LRC circuit has got resistance that is equal to 60 ohms. Right, the inductor is having a value of zero point 0.8 Henry, right, and the capacitor is having a value of 3 times of 10 to the power of minus 4 farad, right. So these are the given parameters you are having. The AC source is having a voltage amplitude of 90 volts. So the voltage amplitude is 90 volts, and the frequency, the angular frequency omega is 120 radians per second. Right. Now you have to calculate the minimum energy that is stored in the inductor. Now this is pretty simple. So what you can do here is you need to calculate the current through the circuit, right, or the RMS current through the circuit. So for that you need to calculate XL, which is the inductive reactance, which is omega L, right? So it's 120 times L is zero point 0.8. It will be in ohms. So let's see how much we're getting. It's 96 ohms, right? XC is the capacitive reactance, which is 1 by omega C. That is 1 by omega is 120, and C is 3 times of 10 to the power of minus 4 ohm. So let's see how much we're getting. It's 27.8 ohms, right? From here you can calculate Z, which is root over of r square plus xl minus xc squared. This is equal to the resistance is 60 squared plus here you will be having 96 minus of 27.8, right, whole squared, and this is equal to it's 90.9, right, on 90.85 you can write ohms is the value of Z, right. Now you have the current I that is given by this V by Z, right. The potential that is given as 90, right, 90 over 90.85 amperes. So there is a current I which is around 0.99, right. Now the question is energy stored in the inductor E, which is EL I'm writing, which is half Li square, right. So it's half times the inductor value is zero point 0.8 times 0.99 squared, right. This is equal to 0.393 joules. Now similarly you have to calculate how much energy is stored in the capacitor, right. So this is pretty simple. So what you need to do is you need to calculate the potential across the capacitor, which is nothing but I times of XC, right. So it's 0.99 times XC is 27.8 volts, right. So this is equal to 27.5, right? Volt is the potential across the capacitor. So the energy in the capacitor will be equal to half CV square, right. The value of C is 3 times of 10 to the power of minus 4, and potential is 27.5 squared joules, right? So let's see how much we're getting. Point 4 joules, right? I hope this is clear to you, and have a very good rest of the day. Thank you.